Okay, I should be live now. Only 9 minutes late. I had a bit of a slow morning, but that's okay. All right, so this stream is going to be another tech stream, more development on my underwater ROV I'm making. Um, so far, my last stream ended with me attempting to fix this model and getting mad and just stopping because I tried to change one little size of a pipe and everything exploded. But thankfully, I've got that figured out now. So even if I try to move this, nothing's going to explode, though it will freak out. I think modeling each individual pipe in SolidWorks made SolidWorks sort of freak out on me. So this might not be the type of model that I can add too much to. Hence, otherwise it might go boom. But yeah. So there's a few things I'd want to add to this, but my main focus for today, I want to be on the electronics side of things. So basically, how the heck I'm going to actually control the motors and what I'm going to control them with, etc., etc. I have, despite being an electrical engineering major, I don't have as much experience with that as I would like. So I know Arduino can be used for this sort of thing. I just need to do research onto how. And I don't even know if I do need a microcontroller, but I don't know. I kind of want to use like a GameCube controller, or not GameCube, but the same sort of like layout, the dual joysticks and buttons. I want to use that sort of setup because I feel like it would be easier for me to control, a little more intuitive. And this isn't going to the Titanic, so I don't need to worry about that. Hello, Clementine. My child needs attention, of course. But yeah, so I figured this stream will be mainly me figuring that out. And oh my goodness. Once I figure that out, if I have time for in the 3 hours, then I'll model the little wire holder at the top here, and maybe I'll 3D model a camera mount for my GoPro. But apparently, I am needed for pets right now. Do you need my attention? Oh my goodness. Hello, sweetie. Hello. Ay, ay, ay. Cats, what are you gonna do? So, yeah. Um, in terms of, I don't know, I'm just gonna have to look up how all this works. Because programming controls should not be that hard. I've done similar things before in previous robotics competition settings. Like, normally it's just a couple lines. This thing isn't going to be autonomous, so I don't need to worry about that. I don't need to worry about state machines or anything. I just need to worry about the basics. And petting my cat, who is needing my attention. Every time I stream, she's decided that it's her petting time. And she needs me to pet her a lot. Silly girl. Silly girl. But yeah. Um Other than that. Oh, I could also put up some music. I mean, I realized that some of the audio gets muted, but it's mostly fine, you know? Oh, and my last art stream I did, I played a Squidward AI cover of a song that got copyright claimed because I guess it was too close to the actual song. So, rip, but that's okay. Um, won't be doing that, but the other songs in Streamlabs should be fine. So I will play those just so we can have a little bit of background noise. Right, do that, and then we'll go to the ROV section. Or not ROV, what am I talking about? We'll go to the internet and try to figure out how the heck you control things. And would I need to like hook it up to my laptop? Or could I just control it through an Arduino? Or I don't know how that would work. Alright, it's gamer lounge time. I should get a Spotify and like get a different playlist because I don't know, like a playlist that like I actually make. Because these Spotify ones, these Streamlabs ones are like, they're okay, but they're not like great, you know. Alright, I guess we'll start here. Jeez, I forgot how loud they are at the beginning. Okay. Let's get some internet going. And let me switch my stream screen. If it would let me click on it. Alright. Oh. I thought that would do the little transition thing, but I guess not. Alright. Yeah, it's weird that it needs to, like, reset that up every time. I might need to look into that, but... Alright, let's see. I guess I'll just look up the basics first. Just, like, how to control motors. Like, how to hook up a motor with a controller. To hook up an electric motor to a controller. Motor controller board. Oh no, motor controller. I'm not talking about to a game controller. So, do I need a computer involved in this process? Or can I just do it all through the circuit board? Okay, they use Arduino. Let's see. Oh. Sure. I controlled servo motors with an Arduino and joystick. Okay, so let's see here. Well, I'm gonna need the computer to program the thing, that's for sure, but hardware this project is very easy to make. First, connect the joystick module to the Arduino. The connection for the joystick module and the Arduino are as follows. Okay, so here's the wiring diagram. And these just plug in, okay, so those are like 5 volt. But my motors that I want are gonna need different power pins than this. Because, I mean, they're gonna take like a max of 24 volts, right? Okay, so I'm probably gonna need to make my own circuit for that. Connect the black wire on both the servo motors with the ground on the Arduino. Red wire on both servo motors, 5-volt pin. Yellow wire on the first motor with pin 8. Okay. It gives values from 0 to... Okay. And here's the code. Okay, so this seems relatively simple. Oh, by the way, my motors that I ordered haven't gotten here yet, so I'm unable to like set any of this up right now. But I'm just doing the research and seeing what things I would need to buy, if I need to waterproof anything, which reminds me, I'm gonna need to get a long cord for the motors. Like, their wires, I need to open their page again. The wires to those motors, I don't know. I'm gonna need to get a wire extender for sure, but what kind of wires, you know? Because this is all just code. I'm more worried about the circuit setup. I mean, this seems... What is this music? I mean, this seems relatively simple. By relatively, I mean very simple. Okay. I don't see where the Arduino gets its power here. I guess the Arduino in this case gets its power from the circuit board? I mean, from the computer? Not the circuit board. I mean, it is the circuit board, so... Okay. Arduino... I mean, I've always wanted to get an Arduino and mess around with it anyway, so... Might as well, right? This music is distracting me. It's like dissonant, you know? Hold on. I am distracted by this. Hold on. How is this in any way study girl lo-fi? Wrong. Okay. What do? Okay. Yeah. Let's go take a look at those motors again. Underwater thruster. Go here. Wow. Meow. There you go, sweetie. The child needs attention. Let's take a look at these. Those little wires can take 24 volts. It's kind of surprising, honestly. Okay, now that I have it hooked up here, let's take a look at this video. See how they hook up their motor. Well, can't really see it when it's moving. So they just have like a wire cover, and then like those, just the two wires. I mean, it seems relatively simple. And then you take those two wires and plug it into the Arduino. So let's look up an Arduino. Arduino. What kind of Arduinos are there? Arduino Uno. I think the Uno is the one that they had. Oh, it's only 20 bucks. Sweet. I thought it'd be like 80 at least. Arduino, do they have like a circuit layout or something? Datasheet, there we go. Yeah, DigiKey is a good site for getting electronics from because they actually give you data sheets. Okay, so its operating voltage is 5 volts. So I can't run 24 volts into this thing. I'm gonna need to make some sort of voltage regulation circuit. So the Arduino is basically just going to activate whether or not the motors get access to their 24 volts or not. I guess.
I don't think.
So that means I'm gonna need a motor controller. Also, little guy's not moving. Oh, there he goes. There he goes. Okay, power tree. Oh no, I can take 24 volts. It says so right here. So VIN, input voltage from VIN, and where's VIN? Where's VIN? Kitchen core. Where is VIN? I'm not quite seeing it here. So analog pins we're gonna need. Does it have 6 pins? I don't know if it does. Okay. USB connector. So there's 5 volt and there's VIN. So how do these two differ? We got the 5 volt pin. Here, let's see what it look like. No, it doesn't show me very much. That doesn't show me very much either. Alright, let's go images. Alright. So okay, there's the VIN pin right there. And then there's 5 volt, 3.3 volt, reset, and current ref, probably. Reference current. Probably, could be wrong. I wonder how this Arduino is actually made. Like, before my electrical engineering classes, all this looks like just magic to me, but now it looks a little less like magic. Still does, but like I can start to understand it a little. Taking a class on how to actually make one of these would be pretty neat. That would be, don't get me wrong, it would be hard to understand. Okay, so we got our voltage in, and according to the data sheet, you can put 24 volts into that. Yeah, max 24. It's probably a little less, but you know. USB, okay, so I think the USB connector is the 5 volt input, output. Operating temperature, yeah, we're fine. Oh. But, okay, so if that's the voltage in, where does it go out from? Okay, we looked up this, right? Okay, so let's take a look at the pins that they give. We've got digital input there, analog input there, and then this is the output. So this plugs into the power, and so does this. Are these the same wire? I guess. Yeah, they must be. So all these plug into the 5 volt pin. Okay, so these plug into the 5 volt pin, but I guess they're getting the 5 volt power from this right here. Okay. So if I were to plug in something to the VIN, like my own voltage from a battery, then how would I get that out? Like, where would I plug that in for the power? And also, these need to be... Okay, there's ground right there. Oh, interesting. So, these, the ground for this and the ground for this is different. Why is it different? So we got two grounds. This ground pin is for the analog joysticks. Interesting. Okay, so I'm getting a little confused here as to where I would put the power for my battery. So we got the ground here. I'm assuming this is input, the different inputs. This is digital. But the motors aren't, I mean, we want it to be an analog response, right? So why would it connect to a digital output? Because we're not just doing 0 and 1 unless that's what they're doing. So you apply the condition of the code. It gives values less than that, greater than that. It's their whole move. Okay, so maybe their code is just like, yeah, their code is like a digital sort of output. It's like when the joystick is in between certain values, then the servo will turn all the way. And when it's not, then it'll turn all the way back the other way. I think that's what they're doing. Yeah, because yeah, initial position 90 for both of them. And then it changes their initial position to 180 if the joystick position is the correct spot. I think. Yeah. Okay, so this is good and all, but I need it for like motors, not servos. I will keep this page up. Speaking of nothing to do with that, I need to go to the bathroom. So I'll be right back. Of course, it's gonna be a classic thing for me, isn't it? Alright, well, now I can transition to an intermission screen, which I need to make still. But for now, look, black screens. I'll be back. Hello, I return. Also, if you hear noise in the back, that is the sink going off. I don't think you can. I was reading my desktop audio and I thought it was my mic audio. Okay, I'm ready for noise suppression. Look at that. I'm back. Okay. What do? Right. Motor to Arduino Uno. Okay. So they're using their own power source that isn't 5 volts, or are they using a 5 volt power source? Because I want to see how they lay it out here. DC motor, Arduino Mega. Well, they're using Arduino Mega. What's the difference? Am I going to need an Arduino Mega if I want to actually use motors? Mama. Hello, Clementine. Okay, set values Arduino pins 8 and 9, use digital wire function. Okay, here's the code. I'm guessing that, I don't know how they're controlling this. I guess they're doing control setup? I guess they're just doing a program to turn it on and off instead of like using a controller. And that's fine, I just need to figure out how to actually set it up to its own power. And I don't think they have their own power here. Alright, they're using a red light.
Harbor Freight. We do business differently from the other guys. We design and test our own tool.
Okay. So is that 5 volt? No. Looks like 6 volt.
In one direction. If you want to reverse the motor's direction, you'll need a part called an H-bridge that we'll cover in the next video of our Arduino tutorial.
So I'm going to need to make my own motor controller circuit for the... Oh, motor controllers exist, right? I wonder if they sell them for this. Mama. Hello, baby. Let's see. Motor controller. Okay, so they do have motor controllers, but they might not be for the... It's kind of expensive. For a motor controller? And I was doing this one. So it's 24 volt. Let's see what this is. I'm gonna need, I should have ordered these two. Okay, so by the looks of this is where you plug in the power. This goes into the, maybe it goes into the pin of the Arduino. Okay, so we'd have our own power distribution panel where all the motor controllers get plugged into power. And then the input and output of those controllers is dictated by the 5 volt pin of the Arduino. That's what I think is happening here. So take a look at this. Yeah, because these are all on the same power. Servos, you don't need motor controllers for, because they take 5-volt inputs. Okay. You know, these are things I should already know. But it's fine. 20 amp unidirectional. Okay, so what are the... Okay, I want bidirectional, right? Yeah, I want bidirectional. 45 uni. I don't need 45 amp. 20 amp bidirectional. I should have just ordered these earlier. Alright, well. Okay, let's take a look at their little video here. Okay. Phase wire. Okay, so that the 3 wires plug into. Okay, so this isn't even the motor controller I need. Mow. Okay, so this is not the motor controller I need, actually. But yeah, it does look like I was right. See how they're hooking it up here. So take a look at this. This is connected to a power, like a voltage power source. And that's where they connect the power of the panel to. And they plug the end into the motor. They plug the other end into a, for them, is basically their equivalent of the Arduino. Oh. Hey, Green Tea Cat. Welcome. Yeah, no, I thought that my stream started at 11 today, but it started at 1 actually. So I was like, oh, thank God. And then I slept in until like 12:30, and I ended up getting, so I got up super late, and then I was like super tired, and I started stream 10 minutes late, and the rest is history. But here we are. So yeah, right now I'm figuring out how I'm going to control my motors that I bought. They haven't gotten here yet, but yeah, I need to figure out how I'm going to control them if I need. I think so far I've decided that I'm going to use an Arduino to do so, which is basically like this little circuit board that you can program. I think the programming software is free, and this is only like 20 bucks, so it's pretty good. And this part is going to be above water for me. Like, all the stuff that's going underwater, I need to make sure is waterproof, so that's what I'm working on right now. And I'm looking up what's called a motor controller, which is basically a little converter that allows me to use the power, like, because the motors take 24 volts of power, but the Arduino only takes 5. So you don't want to plug in the 24 volt power source into the Arduino because you will fry it like shrimps on a Barbie. So basically the Arduino tells this little controller whether or not to grant the motors access to the 24 volts of power using its 5 volt in and out sort of source. So that's what I'm doing right now. I'm just trying to figure out the right kind of motor controller to get. And so far, I was thinking about getting this one, but then I realized that the plug is the wrong kind. So let me just go back to, let me just go back to the motors that I was looking at before. Okay, this isn't right. There we go. UG500 Mini, that's what they're called. Okay. Yeah, see this little wire right here? I'm gonna need a motor controller that plugs into that. Oh, I totally forgot you got a GMM shirt. That's cool. But yeah, we need a motor controller that plugs into this bad boy. So, needs to take the 500 Mini and needs to be able to handle 24 volts. So let's... Ooh. Going to the city sounds like fun. You have any plans for what you're gonna do in the city, or are you just gonna chill? Just look around? And also, do I even need motor controllers from this site, or can I just get my own motor controller? That sounds like fun. Do you know when you're gonna head out, or are you just thinking about it for now? These just straight up aren't motor controllers anymore. Okay. Yeah, I asked when. Cool. So yeah, let's look up motor controller 24 volts DC for brushless. Oh, H bridges. I can't believe I forgot about H bridges. Cool. You have to tell me how it goes. Send me like pictures or something if you see something interesting. Can't believe I forgot about H bridges, dude. For those, well, if you don't know what an H bridge is, it's essentially what I've been talking about, a motor controller. But it can do two motors instead of just one, and you plug it into a power source. But yeah, I use these in my capstone project in my electrical engineering major, so like I use these a lot. I can't believe I forgot about H bridges. Oh my god, it's like seeing an old friend again. Except, no, we were friends. H bridges and I, we were friends. They never did me wrong. So let's take a look at this. Let's... what the heck? Okay. So I would need 3 of these. Take a look at their data sheet. See how many volts they can take. 11 volt max. I can't. 11 volt max. These are tiny H bridges. No wonder. The ones I was using were bigger. 1.5 at peak. Yeah, no. These too small. Too small. Let's get a little bit of a beefier one. 24 volt. I should have just read that. It's not from DigiKey though, so they don't have a freaking data sheet. Let's see if they write anything good about it. What is that? It looks fun. Ooh. So, here's my question. Am I gonna have to make my own controller? Because that would be... I don't know, I feel like that'd be kind of fun. Making my own controller. Alright, so... I see these are 2 different pins for the motor controller. We've got the 5 volt control inputs here. Let's take a look at this. Okay. 5 volt signal power indicator. I0 ground. 10 amp fuse, 15 amp fuse. Okay. So this is the power. This is where you plug in your battery that provides your 24 volt input. It says you can take a max 27, so that's good. And this is where you plug in the wires from the motor. These wires, see? You plug those 2 wires into these 2 ports. And in this 5 volt input here, this is where you would plug it into the Arduino. Where's the Arduino? Yeah, you plug it in, see this 5 volt, this 5 volt output right here? That is where you would plug that into. Like this diagram. See where it says 5 volt right there, and that plugs into the servo. Instead of a servo for us, it would be plugging into this little H-bridge module right here, into this 5 volt input. And EWNMI. Oh man. I actually do have... Oh no, I don't have a robot with me. I had a robot that used an H-bridge, but it's back in my parents' home. So I don't have it with me. But it shouldn't be that hard to figure out. Okay, so this should be relatively simple. Every time I get back into making stuff, I realize how much I like doing it. You know, like it's been a bit, but it's like when I get back into it, it's like, oh, this is actually fun. You know, this is something I actually enjoy doing. You know, classes make you forget that sometimes. All right. So we got. All right, I think I'm seeing how this is gonna hook up. So I could draw it out actually, give a more visual indication of what I'm talking about rather than just mumbling. Let's do that. Not just for you, but also for me. I'm opening up Krita, by the way, but you can't really see it because I haven't transitioned to the thing yet. I'm gonna do a beautiful programmer art rendition of what I'm talking about here. Let me transition my screen. Do I even have it? I don't think I have a Krita source. Alright, let's do a new source. Window capture, add source. Add a new source. Yeah. Node. Krita. Bring it right down. Wait. Wait. Why my Krita look like that? Is that... Did I do a wrong thing? Yeah, okay. I think I did something wrong, hold on. Things I should have set up beforehand, but I did not. I think I did window capture on accident. Alright. Data. Specific window. Krita. I guess, okay. I guess that doesn't count as a game. Ah! Stream struggle. It's alright. I'm more used to struggling on screen now. So it's not as awkward. I mean, it's still awkward, but it's not as awkward. There we go. This one. Why is it showing my Streamlabs when I do that? That's the part I'm confused about. Well, it's fine. Yeah, because like, you see, when I transition, this is what you're seeing, but you're supposed to only be seeing this window right here. Which, I mean, when I minimize this, you can, but it's only supposed to capture this window, you know? Or... is it? I think it's... okay. Something is clearly confused here. What the heck? It's supposed to be capturing my Krita, and it's just like capturing a snippet of my Streamlabs. Why is it doing that? Why do you like this? Maybe edit? Capture method, window. Okay. Why did I have to change the capture method to Windows 10? I don't know. Weird, but we got it fixed. Alright. Just double checking you can actually see what I'm doing here. Made a beautiful little line. Okay, cool. Alright, so let's draw this out for everyone's sake, mostly mine. Alright, so here we got, you can hardly tell that that's blue. Alright, here we've got the Uno. So let me write that in there. Oh, that's the ugliest N I've ever written. Uno. This is our circuit board. And then we have we have our H-bridge module. Right here. Let's call it HB for short. That is a B. And then we're going to have our motor, which I guess will just be gray. Have that over here. Oh, and also our controller. So motor. And then we've got our controller, which what color do I make controller? Doesn't matter. Straight up doesn't matter. Let's do purple. Why not? Alright. Alright. This is our controller. This is our Arduino Uno, which is our main circuit board. This is our H-bridge module. And this is our motor. Here, I'll indicate the motor has propeller on it with a line here. Motor moves indicated by the bubbles. And alright, so the H-bridge module has two of these, but I'm only going to do one for this drawing. So this is where the motor plugs into the H-bridge module. Okay. The motor has power in and power out. So it goes like this. This plugs into the motor here. This plugs into this part. Like this. So this is how the motor gets powered by the H-bridge. And we'll denote that positive, other color, negative. Well, it's ground, but yeah, so this is where the voltage from the battery is going in. On their thing, they had their little power input is green. So... oh, I forgot to also draw the battery. Whoops. I'll denote that with a little lightning bolt here. That's the ugliest lightning bolt I've ever seen. That's where the power from the battery comes in, which is also... I guess we'll do the battery in yellow as well. So this is our battery, let's say, our 24-volt battery. Let's just do a little, I don't want to write battery, so 24 volts. Don't ask me why I'm using the thickest lines I can for this. So the battery has a power and a ground output, positive and negative, which go into here. And get red. So our battery gets plugged into the H-bridge module, and then our Arduino tells the battery, well, tells the H-bridge module what to do through an input on the H-bridge module, say just like around here. Alright, and okay, so where does the Arduino get its power from? That is my question. Oh, is it too loud? Yeah, every time I set up Streamlabs, I have to basically turn it down to nothing. Here, is that better? Of course, I'm changing the music right as the music starts fading out. Classic. Alright, let's wait for this one to fade in. Maybe that was just a loud sound. Because I can barely hear this one now. Hey, it's another ViewBot comment. Hooray. Okay, thanks. Can you delete that ViewBot comment? If you can. If not, it's fine. But hey, I get another commenter on my video. Let's go! Let's boost those statistics, even if it is a robot that's trying to peddle views. Thank you. Okay. So... Welcome! I'm currently trying to design a motor controlling system for my underwater ROV that I'm developing. So, trying to get these motors controlled. I don't have too much experience with this, but I'm figuring it out. Right now I'm drawing out the circuit schematic, a very loose circuit schematic for what I'm going to be doing, which is, this is my underwater motor. This is an H-bridge module, which is a motor controller that allows me to control the motor going forward and backwards. This is an Arduino Uno, which I'm thinking I will be using for my control purposes, and this is my controller, but I'm not done drawing up the schematic right now, so that's what I was doing right now. I was about to go take a look at my little Arduino board that I have. Okay, so the Uno has a pin, and they're gone. That's probably the that was probably the ViewBot thingy anyway. Alright, so this is like the power board here. Yeah, I figured that as soon as I see numbers like go up beyond 2 when you're not in chat, when you're in chat, I should probably like explain what I'm doing instead of just like number. Oh no. I mean, I still go number, oh no, but now I should try to like at least do something about it, you know. Alright, this is the digital input outputs. This one has lyrics. And this one's probably gonna get muted. Oh well. Just looking at my Arduino picture I have. Alright, and they have like a computer program port here. Plug this in to program the Arduino board. Some of this, I need to get a Spotify because some of the songs in this playlist are whack. I guess that's the power? That might be the power for the Arduino. Okay, I think, here, let me draw it out. So it's like this. So there's like this is like a circular sort of thing. It looks like you plug in a power cord to. This is like a printer cable, if you've ever seen that, which is like, you plug it into a printer, but you also plug it into this to program it. So like printer to USB cable sort of deal. This is the analog, which I should probably denote with, goes 0 through 5, so just do 5 tally marks here. Well, 6 tally marks, I guess. 1, 2, 3, 4, 5, 6. So these are the 6 analog inputs. You should get a smaller thing. And log. And then the pins over on this side are the power. Oh. Analog inputs. And then the pins over on this side are power. Which is like, there's V in, there's 2 pins of ground. And then there's 5 volt, 3.3 reset, and IO ref. So 5 volt, 3.3 reset, IO ref. I don't know what the last 2 did. But let me denote it anyway. 5, but yeah, 3.3 volt. Reset I0. Okay. And this is B in. I think, yes. And this is power. Power. I'm gonna have to move that big old Uno. Give me a second. Color pick you. Alright. And these top pins are digital output. Yeah, they're all digital. It says digital / PWM. Oh, some of them are PWM. And the PWM stands for pulse width modulation, which is specific for servos. Servos need to be controlled by something called pulse width modulation, which is essentially the output voltage is pulse to the servo. And for servos, they need that to control like the angle that they're going to rest at. It changes with the length of the pulse of the output. If that makes sense. It probably doesn't, but basically PWM only for servos. And it looks like they have 6 servo ports and 6 motor ports. Whew. Okay. The Arduino Uno has enough motor ports for me. I need 6 motor ports. And they have 6. Good. Whew. I mean, I would just need to get a different board if they didn't have enough ports, but thankfully they do. I haven't ordered anything yet, so we're all clear. Okay, so these top pins are digital. This is for DC. This is for PWM. So this is motors. This is servos. And according to this picture, 0 and 1. I don't know what those are. 1, 2, 3, 4, 5. I don't know what TX. The 0 and the 1 are denoted with TX and RX. I'm assuming that you don't use those ports, but I'll write them down anyway. So 0, 1. It goes 0 through 13, and then ground and A ref. I don't know what A ref is. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, ground, A ref. And not all of these are straight lines, actually. Okay, A, R, G, oh god, G, and then okay, so why is it in such a weird pattern? So this has like an arrow like this. This has an arrow like this. Don't know what those are for, but I'm just going to ignore them. And then there's... Okay, so this one has a squiggly. Here, let's just erase the ones that are squiggly. So that one's a squiggly. Wait, no. Yeah, wait. No, yes. No, yes, wait, what? Okay, so not squiggly, squiggly, squiggly. Not, squiggle, squiggle, squiggle. Not. Okay, so that's 6 pins of each type overall. So squiggle, 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 squiggle. So anywhere there's a little squiggly, that's where you plug in a servo. Anywhere where there's a straight line that isn't denoted with a letter is where you plug in a motor. And all of them get plugged into ground. So I should just label ground with like a ground color. I'll do brown, because the ground often is brown. In real life. In circuits it's black, but it would get hidden. So that's the ground pin. Okay. So for our H bridge, what would we do? I think, okay, I think I got it. We would take this. Let's make these smaller wires because they're not as beefy. They're not getting as much power. So the power for this would go into, according to this diagram, which you can't see right now, sorry. We'll go into the 5 volt. Oh no, these are the PWM. Dude. Normal motors don't need PWM, do they? I don't think so. How would you hook this up? I mean... Okay, here's how I think it's gonna get hooked up here. Which could be wrong. I'm gonna make it its own layer. I think. So... This... Power for this... Good. Would I get hooked up to the 5-volt pin? Or would I get hooked up to the... Okay, now I'm confused. I'm going to switch back to this. Here. Let me switch to the internet so you can see what research I'm doing. Transition. Alright. This is servos. This is not exactly what we need to do. But... See, in this diagram, they have one servo plugged into a PWM port, one servo not plugged into a PWM port. Which is confusing to me. But, okay, let's take a look at the H-bridge. Where'd you go? Oh. So they have a PWM input. PWM input. Do I need that? I don't know. But you see what I'm talking about here? This is where the power goes in. 5-volt input goes into here. Also a ground. The ground is easy. I can do that. Let me swap her real quick. Swapperoo. So the ground will go like this, and it would plug into here. That's the ground pin for the H-bridge. Yeah, I'd plug into the ground for this. Now the real question is, do I need PWM at all? Or do I just go V in? Well... Oh. Okay. Well, sorry if I read your message a little too late, but I hope you have a nice time going out. Yeah, if you're going to be heading out of chat, then I'll talk to you later. But if not, feel free to use me as a background chatter sort of radio, I guess. Thank you. I will attempt to have fun. I am having fun. Yeah, I should have time to do sketches tonight if you want, so... Yeah, I'll let you know. Okay. Bye-bye. Thanks for hopping by. Alright. Oh, I forgot to switch my monitor. So we got the ground done, right? Then we transition. Screen sharing might just be easier. I don't know. But okay. So does this work for servos and motors? So this motor speed controller, motor regulator board, control module industrial. Okay, this doesn't mention anything to do with servos. PWM, is that what's needed? I think that's what's needed to tell the motor to go forwards or backwards, maybe? Okay, see ya. Oh god, I don't. My memory is failing me. Mm. Mm. Do I need PWM for that? Or is it just 5V in? And ground, of course. I might need PWM. I might need PWM. Okay. There's input 1, input 2. And Input 1, input 2, ground. I think you need a 5V reference voltage. And then, oh, no, I got it. So, I am correct. You are going to need these cables to plug the motors into. The squiggles are for servos because they send out a pulse, but the straight lines are for motors because they send out just a straight voltage instead of a pulse. And how it decides whether the motor is going to turn basically positive or negative is how these two voltages compare to each other, like the 5V input and the control input. So I think I'm right on this. I don't know. I'm just gonna say it for now. So you would plug this in here. This would go here. Sure. What kind of line is that? Ask for a straight line. Okay. So that would go into the 5V input there. Still a question of where the Arduino is getting its 5V power from, which I think it's right there actually. See, then I'd probably need some sort of 5V power converter for the battery. I'm still undecided if this is going to plug into the wall or not. I mean, for this little test, it might be easier to not. Oh, it might be easier to not, because I don't know how close I'd be to a wall plug. But if I did do a wall plug, I would just need to get a voltage converter for like 120 to 24 and then 120 to 5. Plug it into both of these. It would work the same, except I wouldn't have to worry about running out of battery. So that's a pretty simple change. So for now, I guess I can denote that with like 5V. Because I need to make sure I know where my Arduino is getting its 5V power from. Getting its power at all from. So, I don't know why the 5V battery is bigger. Oh no. Wait, oh, that's on the wrong layer. This is something I know, not just I think. Go here. This is 5V battery. And then this plugs in to, I guess they both plug into this? It doesn't really say. But I think this is how this works. So that goes into there. Gives the Arduino power. These can be hooked up to the same thing. I don't need two separate batteries for this. But this is just like a basic sort of thing. So that's the 5V input. And then I'll say that the PWM cord, let's make it blue. So it could be any of the ones that are the straight lines that aren't denoted with letters. So let's say this one. Let's have it move over here. Oh, put this on the I think layer. Have it move over here. And it goes like there. And jump. Okay. So I think this is how we'd hook up a motor. You got your control pin here. You've got your 5-volt reference input here, because this is always going to be outputting a 5-volt. It's a constant 5-volt output. This is the thing it compares it to control the motor. And this is the ground for this. And this ground will be the same for all the motors, because this ground needs to be referenced by this voltage here. Because sometimes you have different grounds, because ground for a circuit isn't necessarily 0 volts. Sometimes you can have what's called a reference ground, which is like a different kind of voltage, like a different level of voltage for your circuit that acts as ground. So you want to make sure that the ground for all the motors is the same. So you want to plug it into the same ground pin. Okay, so this is how you control one motor, methinky. Let's take a double look at the... Yeah. ENP, ion. Okay, so there's 4 labels up there and then a 5-volt. Okay. So there's 5-volt ground. Let me switch screens again. Just so that I can confirm with myself. Oh, it already did switch. Wait, what? Oh, did I never went back to Krita, did I? Oh no. Whoops. I was drawing. Well, I'll show you what I'm doing here, and then I'll switch to Krita again to show you what I drew. So, hey. Alright, so you see the 5 pins up in the sort of like this corner right here? This top one is where you put in the 5-volt reference. And then ENP, I'm not sure what that is, but in1 and in2 are where the 2 controls for these motors. So each one of these is one of the inputs. And, well, it's the output. One of the motors plugs into this. And then input 1, input 2, and then ground at the bottom here. So let me actually switch to Krita this time to show you. Ciao. So here is how I think I would set it up. This is the power for the board that gets plugged in here. This is the 5-volt output. That is the reference voltage for the H bridge, which is our motor controller. Then we've got our ground for the H bridge, which is this ground, not this ground, which I didn't label, but it's fine. Then we have our PWM, which is our control signal for the motor, which decides whether it goes positive, negative, or 0, based off of this reference voltage. And this is our actual power for the motor, because the motor takes a lot more volts than 5. Otherwise, we just plug this directly into the motor. Well, no, we wouldn't. But either way, this is how we would hook up the motor. We would need to do this 6 times because we have 6 motors. And we still have room for some servos, which, if I want to do some of the stretch goals we were talking about earlier, could be cool to add some servos. But we'd have to find waterproof servos. But anyway, we're not working on that right now. So now, we need to figure out how the controller is going to hook up to this. So, let's take a look back at our other diagram. I need to make sure to switch the screen. Okay. Well, the bass on this song is kind of crazy. So right here, they have this is a single joystick, which they have 2 analog inputs for. Okay, because the joystick, that makes sense. It's the joystick is it has 2 axes that it moves on. The x-axis, which is like this way, and the y-axis, which is this way. So it has 2 analog inputs for each axis. Well, 1 for each axis, which ends up being 2. Then it has the ground pin that goes into here, and it has the 5-volt pin. Okay. And that's how it controls. Well, yeah. So it's plugged into this 5-volt pin. That's how it gets its power. The analog inputs go into here. They come out in the digital pins via programming. Wait, hold on. uh, oh, it's okay. No, you don't need to worry about that. But that is hilarious. Oh, Unka Bunka, hot woman. I mean, same, honestly. That is really funny, though. Pretty woman. Me like pretty woman, too. So this is our joystick. I thought you were gone. Yeah. Thank you for sharing your Unga Bunga pretty woman story. That is funny though. Now watch as I struggle to draw a circle with a circle tool. Alright, that's our joystick. We've got power, ground, and then 2 inputs. So we've got power, we've got ground, and then we've got 2 inputs here. Let's say this is X. It's a little smaller. X, and this is Y. And then there's just a random pin here that doesn't do anything. I guess. Don't know why it's there, but it is. Okay, and I forgot to switch to Krita again. Okay, bye! Bye, part 2. Okay, I always remember to switch to the internet. I always forget to switch back to Krita. At least I sort of remembered this time. Alright. So, we got our 2 analog inputs. Let's just call it X and Y for now. And okay, so this would connect where'd my line? Where'd my line? Oh. There, it's in white. Hey. Okay. What? Why is it doing that? Stop that. Just draw a straight line, please. No! Stop! You know what? Fine. Whatever. Okay, so this plugs into here. The ground plugs into the ground, not the same ground as the motors. It plugs into this ground. And then the 2 motor inputs plug into... Oh, the 2 analog inputs go to analog 1 and 2. So that would be like... this... That's analog 1. This is analog 2. I don't know why I did it this way, but that's fine. Line tool is not wanting to play with me right now. Boing. 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 Okay. So this is how you would hook up a joystick to this, which would imply we need to make our own custom controller. But honestly, that is much easier for me than plugging this into a computer and figuring out how to control it through a computer. So, alright. Let's see. Right. So this is the basic setup for one motor. I want to save it. File save as basic motor setup sketch. Pictures. Actually, no. This folder's backwards. This one. All right. So this is our basic layout, methinks, for one motor. We just need to do this 6 times. So, which means for this we would need 6 of these. We need 3 of these. We need 1 of these. We're not going to need a separate battery for this, but we are going to need a circuit for this to convert the battery. So maybe I'll just denote that. I'll draw that in. Gonna need 1 of these. Gonna need 2 of these. And should be good. Here, let me denote the voltage regulation circuit. That would convert this 24 volt to 5 volt. They have him do the jumpy. There we go. It's not the prettiest thing in the world, but it's just a sketch. Just to help me understand. And you, if you also don't know what I'm doing, because I almost never do. And that. And let's lower this diameter. Like, oh. That's awkward. Maybe this should just be a straight line and I'll make this one jump. Because it is on the I think layer. Alright. Okay. So I needed to know what that is. Get some smaller text in here so we can read. 24 5 volt convert. Alright, so that's how this doesn't need to be a battery, but basically this battery, just imagine it's getting its power source from this 24 volt battery, in this case. Let me save this again. Okay, so we have somewhat of a parts list going on here. You know what, let's make a parts list. Let's make a parts list. So that way we can also keep track of our budget. Let's switch the thing. Pow. Blah, 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 blah. Where's Google Drive? There it is. Okay, let's make a new thingy. Google Sheet. Underwater. ROV. Parts. Okay. So this will be our part. This will be link to the part. And I guess this will be the price. And then we can have like a total budget. So total. Actually, that doesn't need to be its own column. But I guess I could break this up too into like electronic versus physical. Well, underwater ROV versus control center, maybe? If we really want to care about that. Yeah, I'll just... Why not? Extra organization. So we could do a running total for the ROV section, the running total for the control section, and then running total for all of it. We'll just put... I'll denote the differences between which is which with colors. So let's say ROV, like the underwater ROV part is blue. The control center is red. All right. And I guess this top column will be purple. Fill color. Purple. All right. So let's do the things we just figured out first. Uno. Arduino. Uno. Alright. And... okay. Where's the Arduino Uno? Go away. Go. No. Wow, 10% off! Am I in the right place? I don't care. Save $20! Eh. 20 euros. Ooh. Perhaps not. Right, this is saying that I could get this Arduino Uno for 20 USD. Not bad. Alright, I'll put this link in here. Ooh. How am I gonna make this cell hide this? Maybe I can edit the link. Okay. And then this goes to... yeah, okay. Alright. And the price is... I say before tax. Before tax. Price before tax. Just what it's labeled as. 20. Alright, we got the Arduino. We've got... we only need one of those. Oh, I should do amount. I need an amount column. Amount. Does that spell right? I always think amount has two M's. I knew I was missing a column. Alright. Alright. Amount 1. Total. Okay, so that's the total for this, and then... actually, I don't need to do a different column. or total? Alright. Total is just equals that. Alright. And then I can copy this and paste it. Alright, so next part is our H-bridge module, which I think I'm going to get this one. I'm just going to call it motor controller, or parentheses H-bridge. Motor controller H-bridge. I guess this column could be longer. The link to this. Let's edit that. Let's edit the link. Link. The price for you before tax is $15.99. For the month. No, I don't need that. I don't need that. I don't know what that is. That's not what I need. So $15.99 before tax. $15. Amount 30. Okay. Next up, we've got joysticks. I have these links so I can exit these pages out now. I'm gonna buy all this off stream, but oh, motors. Well, I'm doing the control stuff first. So looking back at our Krita drawing, battery. That's important. We're also gonna need cables. Also important. Also don't know what I'm gonna use for a converter. So let's look at the battery at least. 24-volt battery. Okay. We've got a few options here. I don't know what the benefits and drawbacks are to each of them. I'm not getting a $94 battery. I should say rechargeable. Rechargeable. Did I spell that wrong? I did. Never trust an engineer to spell. Alright, well, if we're gonna need something that plugs into the H-bridge. Well, it's gonna need to plug into 3 H-bridges, which means I'm gonna need to make some sort of power distribution panel. Or, I mean, okay, the power distribution panel, the one that converts the 24 volts to 5 volts, can also be the one that splits up the 24 volt output into the 3 H-bridges. So I'm gonna need a power distribution panel. I don't know if they sell those, or if I'm gonna have to make one. They're relatively easy to make, thankfully. So, that shouldn't be too big of an issue, but I want to see if they sell one. Because I'm lazy. But if it's too expensive, I'll just make it. $24 volt, 22. What are you? Unreviewed product. Battery without a charger. Lithium ion 22.2. Don't trust it. What about you? Ooh. Maybe you can get one from DigiKey. Do they sell them? I trust DigiKey. Oops. Tag, box, bolt, it doesn't matter. Lead, sealed lead, lead. Oh, okay. Oh. Photo not available. Yeah, okay. Maybe not you. Alright, Amazon it may be. What is this? Okay, so does it come with a charger? I think so. What is that? 24 volt, 1 amp. 20. Quick charge, 24 volt, 1 amp. 24 volt. How many amps do these motors take? 2.5 amps at 24 volts. Okay, so this battery needs to be output that amperage, which it can. It's a bulky little guy. It's $41. I'm assuming this comes with the charger. It does. And it comes with a positive and negative node there. I don't know if this charger indicates when it's done. It does have a little green flashing light. Output port works independently. Overload protection, overload voltage protection. Okay, that's good. Okay. It's just a single cell lithium ion. Indoor, outdoor. Okay. I don't need the $99 one. I think I'll just... This looks like a good option. More expensive than I would have hoped, but it's still better than nothing. Alright. Let's copy that link. 24 volt lithium ion battery. Let's edit the link. The price before tax is $41.99. Dollar for you. $41.99. And we need one of these. Okay. So we got Arduino, controller, battery. We need the joysticks. Joystick module. Alright, these are pretty cheap. I figured so. Now, this one involves soldering. This one doesn't. But it's an extra $1 per. This one definitely requires some sort of breadboard. I'd rather not have to use a breadboard if I can avoid it. Ooh. This one's cheap and it doesn't need a breadboard, I think. Why is it? Oh, it has a button sensor too. Okay. I don't think I need the button sensor, but I think they're all gonna have it. Here. Let's take a look at this guy. Data sheet. Okay, I guess I don't get it. Okay, just give me the... Yeah, okay. I don't know what I was expecting. SK, X, SX, XY, VCC, ground. Okay, K. Oh, that's what the other thing is. I think it's the button. The other input is the button. Well, I'm not gonna need that. But this should be good for what I need, I think. Right. I think this is good. So I need 2 of these. And it is before tax $5.95. $5.95. So joystick. Let's edit the link. And this is $5.95. We got 1. Oh, not 2. 2. Okay. And now we need a power distribution panel. And then we need cords. I don't know where I count the cords. I think I count the cords as the underwater ROV part. It's close enough. So, power distribution panel. Let's look it up. $24-volt. 5-volt converter power distribution module. Okay, this isn't bad. Let's take a look at this one. Data sheet. But could I make one for cheaper? Because I only need 3 outputs for the 24 volts, and I only need 1 output for the 5 volt. And it's a 20 watt adjustable DC-DC buck converter module. Digital display. I don't know why I need a digital display. Step down voltage regulator. 0 to 40 volts. That actually is 8.5. Self-calibration function to provide higher precision voltage output. Commanded input voltage is maintained at 4.5 or more. Touch button to switch the measurement input or output voltage. So this is like adjustable. Interesting. I mean, I do need to make sure the output current is good. But do I need an LCD display for something like this? I don't know. Let's keep this page open. This thing's bulky, guy. And I need multiple outputs. And this only has 1 output. So I'm gonna need, I would either need 2 of those, or no, I just need 1. It was the wrong page. Okay. Yeah, no, it might just be easier to make this myself. But that means I'd have to do soldering. Oh no, the electrical engineer has to make a circuit, and a really simple one. Terrifying. I should. Alright, well, how much are the individual parts for that gonna be? Actually, at my college, there is a place where I can buy components for that. But I can guesstimate based off of what I find online. So, what are those called? Soldering boards, not PCB. Is it PCB? PCB. Soldering board. No. What are those called? The ones that are in between breadboards and PCB. What are they called? Breadboard PCB. Okay, these. Yeah. Alright. Alright, so these are relatively cheap. So I have breadboards. At the very least, I could just do it on a breadboard. I'd rather not. But I could definitely prototype the circuit on a breadboard to make sure that nothing goes wrong. But like something like this would be all I need. So let's say power distribution panel. And this is going to get broken up into two different things. So I'll just leave this blank. And then, actually no. No, this total, well, I'll leave this blank. The total for this is going to be the sum of all these. Which I guess I can denote with a different color. It's fine. Alright, so PCB will go to bills. Price, this is just a guesstimation. Let's do $234. Dollar, $234. Wow. Not that much. Only need one. And the individual components for this. I'm gonna need 4 wire plugs. Should be really cheap. They have soldering equipment there, so I'm not gonna need to buy a soldering iron or anything like that. Just forget what they're all called, you know? Well, voltage regulator. Voltage regulator. 200 volt to 5 volt. Oh, heck. 1.5 amps. I need more amps than that. But yeah, basically how this works is this little thing right here, you plug in the battery to, and then it will output a different voltage. It'll convert the voltage down. You can't convert up, but you can convert down. And that's what this does. Yeah, I'm not getting one of those. So these are pretty cheap. I'd only need one. But it needs to be able to handle the right amount of amperage. So how many amps does the the battery put out? It was saying like 4. What's your amperage? 40 amp hours? 3 to 5 amps. So I need to be able to take 5 amps. Yeah. These are going to be a little more expensive. This is essentially the circuit I'm going to be making. Right here. But the reason why I wouldn't buy this is because, well, this only does it to the 5 volts, and then I would need 3. Like, my circuit is essentially going to do 2 things at once. It's going to split the 24 volt input from the battery into 3 different 24 volt outputs for the H bridges, and it's also going to have a conversion where it converts one input of the 24 volt to 5 volts for the Arduino. So I'm sort of killing two birds with one stone with this thing. And it's power distribution panel. It's not just the voltage converter. It also distributes the power to the H bridges. Okay. Well, okay. Let me think about this. It's actually, no, because this converter I only need for the 5 volt. Okay, so how many volts does the Arduino take? I don't need it to take the whole volt of the battery. Oh, do I? Hold on. No. Okay, let me take a look. Arduino. Data sheet. I know it mentions VN somewhere. VN. Max. I guess it just doesn't care about amperage. There should be some sort of amperage sensitivity, shouldn't there? I guess not. Like, what would burst this thing, you know? I don't know. Voltage input. Huh. Arduino. Okay. Doesn't specify. I don't want to fry my Arduino. So I might do a lower amperage. Because it doesn't need a bunch of amps to convert. It just doesn't. So something like this should be all I need. Got that out. Equal 5 volt converter. And put the name of it in there. I'll put the link in here just in case if they don't have it at my school. There. Actually, kill two birds with one stone. I don't know why I keep changing up the capitals. Alright. Price, 65 cents. $1.65. And I'd only need one. And yeah. Alright. I need that. I'd also just need basically just plugs that plug in, like, okay, let me show you what I'm talking about. See those little blue things? Yeah, I just need those. And, like, wires. And maybe a heatsink. I might want a heatsink. You know what? I should probably get that too. I wonder if it recommends heatsink for this or not. It does not. Heatsink for... Wait, I just copy that. Okay. So this should work. Something like this. I don't think I'm gonna need a crazy heatsink. Basically, why I'm looking up a heatsink for this is these voltage converters, they can get really hot, and it's because they're dealing with a lot of voltage changing, and when you're reducing voltage, that energy needs to go somewhere. Often it gets released as heat. So you don't want your circuit overheating, hence you buy a heatsink, which is basically, it's normally just like a piece of metal or something that you physically screw on to the part, and it disperses the heat throughout the material. So I would want something like this. And it was saying this is 44 cents. And I only need one. Alright, and then I need the wires. So, I don't know what those things are called. PCB wire plug, wire connectors, sure. Yeah, these. Yeah, just something like this, all I need. Or I could get like a 3, or does 3. Because I'm gonna need 4 different ones. 3 for 24 volt. 1 for 4. These are super freaking cheap, as they should be. So do I want to do it with this? I mean, it's also super cheap. Look at that. That's super cheap. Because, like, I don't want them to be removable, right? Like, these are the kinds of parts that you could probably just find laying around in a lab. You might not even need to pay for it, but let's add it into the price regardless. I could get a 50 piece. I might just do that just for me, but I'm not gonna count it all in this. But it has all the different kinds I'd need. And then it's customizable. So I could divide this price by 50, and that would be, and multiply it by 4. And that would be the approximate price that I'm paying. I might just get this, because if I'm going to be making more circuits in the future, these things are really useful. Wire connectors. Here's the link. Might be able to find it cheaper somewhere in person, but okay. So, $14.99 divided by 50. $14.99 divided by 50 is about 30 cents per, and then we times 4. So it's about $1.20. So, yeah, I mean, obviously, $1.3, and then we need 4. Okay, and wires and stuff like that are kind of negligible. wire, solder, I should be able to find there for free. And their price is small even if I were to buy it. So, actually I realized I should move these over a cell. Oops. Like that. So that when I do the total for this, then it won't confuse the thing. So, here. This equals... no. Some... yeah. Alright, so overall I should be able to make this power distribution panel for approximately $4.50, which is a little pricier than the ones that they were showing, but mine does 2 functions at once, so I wouldn't need to buy multiple. So I am saving a lot of money with that, just by making it myself. And it's a really simple circuit to make. I might even be able to make it on stream. I do have a soldering iron. I don't know if I have it with me. I know I own one somewhere. I could do like a little soldering stream with my minimal desk space. Or maybe I'll just record it. Who knows? Okay, so that should be all I need for the controls for now. Well, okay. If I'm doing Ascension... Okay, because we need to control 4 different degrees of freedom. We got forward, backwards, rotation, strafing, that's 3, and then up and down, that's 4. And our joysticks do control 4, 2 each. So basically I would need to map 1 joystick to forward, backward, spin, 1 joystick to strafe, and then up and down. Up and down. Okay, so that would work. I wouldn't need any more, like, buttons or anything. Though I could add more in the future. Okay, so... that should be everything for our controls. Okay. Control... Hold on. Let me reformat this a little. Oops. Forgot it does by the top one. So this will be control system, which is all just a subset. All of these are subject to this. So control system. If I'm going to make my own custom controller, I'm going to need a spot to put it. And I did buy acrylic, but I also bought the acrylic for the wire guide on the ROV. But I should have enough space to use the same acrylic for both the controller and the wire guide, so I shouldn't need to buy more than one. And it's mainly for the ROV, so I'll denote it under the ROV price. Alright. And I said I'd make this red. Well, let's make this top one like a darker red to signify it is a indicator. So, like, no. Wrong thingy. It's like this. And then this is the last one will be the grand total. I should switch these 2 cells. So this is where we go for any subparts. Total. Control system, total. And let's make this a darker color. Signify that we're done this. And the total for this would just be all these added up. Alright, so 126 for a control system so far. Not terrible. Also, I should probably check and see if Arduino programming software is free. Because if I pay for that, then I'll need to do that. Oh, did I put in the... for that? I did. Okay. Right. Arduino software. Is this just a free download? It looks like maybe. Download. Okay, so it's free. I don't need to pay for it. Well, I might as well just download it now. Oops. I agree. Anyone uses computer? Yes, I agree. Install. Alright. Yay, I don't need to worry about the IDE. We'll have a good free IDE. Also, is my model frozen? Okay. Ugh. I might need a better camera for if I'm gonna keep doing the face tracking stuff. Oh, oops, accidentally ran it. Here, buddy. Alright. Oh my lord, just let it do the thing. Art of fruit. Okay. Alright. I have it downloaded. Cool. So, don't need to worry about the price for that. Now, let's get to the underwater ROV. So, underwater ROV. This will be blue. Actually, I just realized I could just put the total up there. I don't need this cell. Whoops. And then I can move you. Make all you blue. And then this equals some of that. Okay. So this is for the whole control system. Right. So, first things first, for the underwater ROV, is the motors. Or underwater thruster, I guess. Under. Oh wait, no. Underwater. Oh my god. Thruster. Ain't easy with me. Alright. Alright. Link. They are $23.91. $23.91. And we need 6. It's not a subpart, so copy you. Paste 143. Hold on. Oh, wait, no, that's right. It's like, hold on, we're not doing that. Just the motors alone outprice the entire control system, which is wild to me. But, you know, it does make sense. Motors are generally the more pricey part of the control system. Alright, so got our underwater thrusters here. And we've got... what else? PVC. Alright. PVC pipe. 1/2 inch. I've already bought this. The price for it. Okay, first off, I think it was like 10 foot of PVC pipe that I bought. I think it might have been. So 10 foot. Foot is a single dash, not the double dash. You can tell it's been a while since I've used the notation. I had to buy it. I think it was around like $6 or so. I have the receipt somewhere. I don't know where I put it, but I have the receipt. And I know that shopping trip ticket came out to like $75. Did I take a picture of that receipt like somebody who is smart? Or did I just sort of put it somewhere? I might have just put it somewhere. I just put it somewhere. Okay. Let me see if I can find it. It might be in my car. Yeah. Hold on. I'll be back. Where'd my little guy go? Is he live? Oh, oh there he is. Alright, I'll be back. I'm gonna go see if I left my receipt in my car. Yeah. I guess. Look at my intermission screen. Intermission. Ka-chow. BRB. Could not find my receipt. But, you know what? That's okay. I at least looked at the parts and sort of remembered what they were. I wish I was more organized than I am. Okay. I have one receipt for when I bought extra of something that I thought I didn't need more of, but I did. So at least have the price for one of the parts. Alright. Let's see. I'm just gonna guess. I think this is around like $6.50. PVC is pretty cheap. And that will cover all my structural PVC needs. Why are you red? It's fine, I can change that later. So. Alright, just add those. Turn them all blue. Alright. Pool noodle. I think it's like $5 You know, I couldn't find a pool noodle. I actually had to go, like, I went to Target. I mean, I did shop for this in January. So, not exactly swim season, but I had to go to like 3 different stores to find a single place that was selling pool noodles, and it ended up being Ace Hardware. It's like, really? I had to go to Ace Hardware to buy a pool noodle? And, yeah, I went out to buy, I think this ended up being like $4. Alright, and so that's for my flotation. Who knows how many more of those I'll need to get. Acrylic. I don't remember the exact dimensions of the thickness, but I know it ended up being around like, I think it was like 37-ish bucks. I could be wrong, but I know it's close to that, and it was a big sheet of acrylic, so it's like 1.5 feet by like 3 foot. But 3 foot. Maybe it could be bigger than that. I wish I had my receipt. Alright, and I also got the tees. So 1/2 inch tee couple. I know how much of these I bought and what price they were because that was on the receipt. So each unit was 79 cents. I had to get 20. Oops. Dollar. And then 1.2. It was not 1.2 inches, it was 1/2 inch. 1/2 inch PVC 45-degree couple. For the angles, went out to buy. Those were a little cheaper. I think they're like 60-something cents each. $1.68, something like that. And I had to get 8. And the last thing I had to get was zip ties, I think. I think that was the last thing. And I'm not counting the 3D printing material because I have access to a 3D printer I can use for free along with the material. So for like the motor holders, I can get those for free. And I don't know exactly how much that specific amount of material will cost. I suppose I could look it up, but I don't feel like it right now. So, zip tie. I think I got like 100 or something. And it was like $9 or so. I think, no, it was like 200 of them for $9. I don't know. It came out at a reasonable price. It was like one of the better priced ones I could get at the store. For some reason, my brain is telling me this price. So, I know that is close. Alright, so I think that is everything that I did. And let's do the running total here. Equals sum of that. Alright, and then we will do a grand total, which we are over budget. But my budget was pretty arbitrary. I did get close. Okay, I got close. Some most random music in here. Like, what is going on? What color are you? Okay, you were that one. Okay. Grand total equals this and this. So we are at 349. Our budget was 300. Okay, maybe not entirely realistic. But, I mean, hey, for just a random guess, it was close. Budget. $1. For just a random guess, not bad. And it is still within the ballpark of something I'm willing to pay. It's just like, okay. Alright, my budget is 3,000. So we got budget. I could do a little budget chart. So, we got our budget, our total, and then how much we are over or under our budget. And then we're under. All right. We are... Okay, so in this format, it being negative means we are over budget. I might need to change our budget. I'm gonna have to if I want it to be fine, but... We're not grossly over budget. Like, this is cheap. The H-bridges, they're relatively cheap. I might be able to get cheaper ones if I go to the school. I could see. But for now, this is our parts list. And this should cover everything. because the IDE is free, and oh no, I forgot the cords. Shoot. The wires for going actually underwater. Ooh, what would I... How long would I need those to be? How long would I need that to be? And I need a lot of them. I'd need a lot of them. And I need something to cover them with. Okay, budget of 300, not very reasonable, turns out. If I'm getting all these parts and not making them myself, that is. And this is with me making my own controller and making my own power distribution panel. I'm just using an Arduino and like pre-made H bridges. Like, what is eating up all my budget? It looks like the thrusters mainly. Thrusters, the acrylic. Even if I took out the acrylic. And these are like relatively cheap thrusters too. Huh. Well, it's good to know this sort of thing before you know, commit. Okay. Brr. Cord. I need cord. Close that. I don't need 30 meters of wire. How long do I need this wire? Like 30 feet. Let's do 30 feet. 30 feet. Wire. Extension. And it needs to be waterproof. Waterproof. I need something like this. With a similar gauge wire. I need to know the gauge of the wire. You know, this is something I could probably just go out and buy. Okay, so we're looking at a we're looking at what? This is pending cord price. I'll move the grand total down here. Alright, right. Wire extension. Build. I don't know how much or how many of these I'll need, but yeah, I guess it's pending. So, $300 budget, maybe not realistic. What would be a realistic budget to spend? Maybe 500? I mean, for a basic something, I don't know. I wonder if there is a way to squeeze it under 300. Because we got our thrusters, we're 3D printing our motor mounts for free. We're making the main thing out of PVC and pool noodles. What are the big spenders? We got the thrusters, the lithium-ion battery, and the acrylic. That's the big money right there. Oh, and the H-bridges. I wonder if there are any cheaper H-bridge modules. And the cord's probably also going to be a big price eater. H-bridge. Does Arduino have H-bridges? Oh, these are way cheaper. Hold on. These are the ones I was using. These are like $6. What was I thinking? Okay. I should just get these. They're way cheaper than those H bridges I was using. Yeah, I don't know. Okay. 2 amps, 25 watts. Can reach 3 amps max, and continue current is 2 amps powered to 25 watts. 245 volts. Yeah, no, this should be fine. Has a built-in 5-volt power supply when the driving voltage is 7 to okay. Yeah, this is all I need. Just 3 of these. Yeah, and my school sells these as well. So, here. Motor controller, H-bridge. Let's change this link, cause me no likey this link anymore. Link apply. Oh. Alright, so this should take me to a much cheaper H-bridge. It's only $455 before tax. That is way better. That is way better. Okay. I was wondering why that was so expensive. Oh. So I just saw. I don't know when you chatted that, but welcome back. Welcome to the park. I'm trying to figure out how to squeeze my budget down for this thing. I set an arbitrary budget of 300. Now I'm seeing where I can reduce the price at all. I hope you are enjoying park. Okay, so this is a way better price for that. Oh, okay. I'm glad I didn't miss it for long. Joystick modules. So, yeah. I guess I could do some additional research after stream if I don't finish it up. I know these are like the cheapest motors I can get for the power that they give. Ooh. Sounds like a nice place. You know, I went outside earlier in the stream when you weren't here to try and find my receipt from Home Depot for when I bought some of this stuff, and I couldn't find it, but it was like, I should take a walk after this or something. So, yeah. I mean, this is something I've already bought, and you know, acrylic can never go wrong. I know that's a bigger spender here, but I'll keep it. Joystick. Oh no, okay. I was reading that weird. Let's see if I can find a cheaper battery. Because if I can find a cheaper battery with a charger, then that might put me sort of under budget. Yeah, it's nice and cloudy where I'm at, and I like that sort of weather. 24 volts. Rechargeable battery. Let's see if we find any better options. What are you? This is not 24 volts. It's 4.8 volts. It's not even 20. $24 volt, that's way too expensive. Yeah, I mean, batteries at this voltage just tend to be a little more pricey, I guess. What about you? 50. Yeah. 24, 48, 95. No. I don't know. I guess batteries are just sort of pricier. What about you? Are you? You are 12 volts, 3.4 amp, 2.5 pounds. How big is this thing? $20-hour runtime. Wait, this is a 12-volt battery. We need 24 volts. Yeah, so This looks like the cheapest 24 volt I can get. But is it rechargeable? I don't see a way to recharge it. According to the, you can swap the, yeah, I'm aware of that. Yeah, how would you recharge this? Is this even rechargeable? I don't think it is. Features. Let's Control F. Recharge. New rechargeable battery first, then reuse. New batteries are generally 3 to 4 times to go through the cycle and charge and discharge. Okay. Yeah, this... Rechargeable batteries are not afraid to use. Well, I'm glad they're not afraid. Aw. I'm sorry the plant store didn't have the plant you're looking for. Yeah, I don't know. This seems fishy to me. But it's the only one that's like the price ride needed. What about you? 12 volts. I mean, you're 4.8 volt. I mean, I guess I could run a bunch of these, but that would still add up to this price. Yeah, there's just no good source without having to make a circuit myself, and I don't know how to make a circuit like that. And that would be an expensive mistake to try to learn when I could just buy a battery that does it already. Is this not the exact same thing as this? Okay. There are high school children everywhere. Ew. High schoolers? Gross! Alright, what are you? Walmart? Yeah. Wow, that's crazy. Must be, maybe like they were coming over to do a school tour or something. Wait, hold on. This one's cheaper. Charger lithium replacement battery. What charger? What is it? Why is it a replacement battery? This one's even cheaper. What is this? What's the difference between this? Different amps. This one has 7 amp output though. I mean, if this is going to be on land and not moving around, I don't need to worry about the weight of the battery. And eventually I might replace this battery with just a voltage regulation system to plug it into the wall. Yeah, no, that would suck to deal with that sort of traffic for every day of school. Dude, I've been there. What is this? Why does it only have 3.5 stars? Most people rated this a 1 star. I don't know. Oh, come on. It's like you can't see views. If I scroll down. I can't. I can't read this. Did exactly what I needed to. Oh. There's not a 24 volt battery as advertised. It's only a 12 volt. Not 24 volt. It's 12. They're just lying to you. Yeah, it says 12 volt. Huh? I almost got gypped. How dare you, Amazon? Alright. Alright. 24. 24 volt. Actually, it's not. What about you? Dude, that sucks. The traffic sounds crazy. Okay, this is like exactly the same as the other thing I got, but just cheap. It literally is the exact same thing, just cheaper. Wait. Oh, it's because, okay, it's the amps. Okay. Yeah, okay. That makes sense. That makes sense. I mean, okay. 2.6 amp hours. What does that mean, though? Amp hours? Like, what's the amp output of this thing? .6 amp. Is it amp hours? What does AH stand for? Oop. Amp hours, yeah. Energy capacity rating tells us how much current a battery can provide at a specific rate for a certain period. Can provide 5 amps for 1 hour. Okay. And since the motors take 3 amps at 24 volts, I'm going to need something that provides more than 3 amps. Hence the 4 amp. Okay. I don't think there's any change in this battery value. We're a little over budget, and that's before we even get the cord. And, okay. Alright. Yeah, I mean, it could be, the picture could be incorrect for the other one, but none of the pictures are correct. And there were reviews that were saying that it was 12 volts. Like, the majority of the reviews of this thing are 1 star, and all the 1 stars and 2 stars say they're not 24 volts. Oh, you're supposed to buy 2 of them and use them in tandem to get 24 volts. Yeah, so basically this is basically like a $60 24 volt battery, which is not what I need. What about you? 6 amps. Number of batteries. 1 12 volt battery required. Included. 12 volt? What are the reviews on this thing? Does it not have any? It does not. I ain't buying it. And plus, it's more expensive than the one I was looking at anyway. Yeah. Alright. I think this is going to be our current budget. I mean, I did sort of set this $300 budget arbitrarily, so it was a little off, but, you know, not nearly as bad as it could have been. The control system's only $92, and the motors outprice the entire control system by themselves, which is crazy. And then the rest of this, and then the cords. But yeah, I mean, overall, my budget isn't very strict. It's just something that I would like to not pay more than. But if we're not far over that budget, that's okay. So, yeah, I think that's good for now. Yeah. I don't know, I think, honestly, well, I'm gonna go out and take a look at, like, prices for things that I can find before I buy all these things online. If I can get, like, a better deal, and I won't have to deal with shipping or anything like that, then I'll do that. But as it stands, this is before shipping tax. I don't think there are any other parts we need other than the wire. So yeah, I think I was gonna try designing a controller, like, or a controller battery mount thing, like basically our whole controller module once we picked out the parts, if I had time in this stream, but I only have like 5 minutes left, so I will do that, I suppose, next time. Or I might record it separately. I don't know. I mean, I only have limited time to work on this because I'm doing classes and I'm working on 2 other projects. So, it's just going to be a little slower. But once all this stuff gets in and I'm able to test it out, it's going to be super exciting. Yeah, so I might call stream here. I'm going to switch my view back to the drawing I did, just to take one last look at it. So, yeah. Overall, a productive stream, I would say. Because before the stream, I just hadn't even thought about how I was going to set up any of the electronic parts. I was just sort of like, well, I'll figure it out later. But, yeah, no, this should be good. And I'm excited to hook it up and test it out, and yeah, it'll be really cool. And when I make a YouTube video on this, it's gonna be sick. But yeah, so next stream should be an art stream. I finished my VTuber model, but I have actually been debating making a new one. Because yesterday I was just really like tired and out of it, and I drew myself as a little zombie, and I was like, you know, most VTubers have like characters that they have, right? I could do a little character. It's just me as a zombie, and the lore can be like, why am I a zombie on this and not on my YouTube channel? Well, I tried to make a clone of myself from scratch. Yeah, here, let me show you. Let me show you the drawing. Oops. Open recent. It's just some loose concept art. It looks really scrungly, but that's because I was drawing with a mouse and I was being lazy. So, yeah, I think next stream I'll be working maybe on this. I could set up a PNG tuber of this guy pretty quick. And maybe I'll work on a live 2D version on stream. So, yeah, something to look forward to for next stream. And, yeah. The reason why I designed it this way is because a lot of times I just feel low energy, but when I take my Adderall, when I take my medication for ADHD, sometimes it feels like my brain is getting powered by something, you know? So when I'm feeling it, I could like switch to this mode. It could be fun. At least for me. But yeah. All right. I think I'm going to call it here. So thanks for watching. I wonder if someone's on that I can raid it to. do you want to raid into someone? Well, you're out and about right now, so that could be cute. Yeah, I don't know how I'd set that up, but I wonder if there's anyone on right now. Oh god. Ooh, Salty's on if you want to raid into him, but if not, I get it. And I've never raided before, so I don't even know how I do it. But okay, you said no, then yeah. Alright, then if we're not raiding, I will just end the stream. Yeah, we'll figure it out. But thanks for stopping by. Glad I had someone to talk to for a little. And sorry, I'm just dying a little bit. Yeah, if you want to see me draw this guy out and attempt to create an actual VTuber character, stick around. Thanks for watching. Bye-bye. I will try not to die. No promises. He didn't look like he had a very good time with that, so we'll see.